Hello everyone, today we'll learn how to prove root 5 is an irrational number. Since root 5 is a irrational number, is a true statement, so we'll prove it by using the hypothesis method. That is, we'll assume that it is a rational number. So let's start. Let us assume that root 5 is rational. Now, as per the definition of rational number, it should be of which form? P by Q form. So here we'll also take root 5 as a P by Q form. So we'll write root 5 is equals to P by Q, where Q is not equals to 0. This is the definition of rational number. There is one more condition that we are putting here for P and Q, that is P and Q are co-primes. What is the meaning of co-primes? Co-primes means the two numbers will have only one as a common factor. Means the HCF or the highest common factor of these two will be 1. No other number can be their common factor. Now what we'll do is we'll take this denominator q on the other side and multiply it. So we'll get root 5q equals to p. Now we're going to square the left and the right. Okay. So we'll say root squaring on both sides. So it becomes square root 5q the whole square and p the whole square. So let's take that. We'll say root 5q the whole square equals to p square. Root 5 square means it's a 5 and q square. So it becomes 5q square equals to p square. I'm just going to rewrite this in a little bit different way or in a more convenient way as p square equals to 5q square. Now can we say here that a square number, perfect square number, has 5 as a factor? So will its square root also have 5 as a factor? So let's take, to understand this, let's take an example. Let's say 100. Is 100 a perfect square? Yes, 100 is a perfect square. So does 100 have 5 as a factor? Can we divide 100 by 5? Yes. So 5 multiplied by 20 gives us 100. Now square root of 100 is 10. So does 10 have 5 as a factor? Yes, 5 times 2. So what we are trying to show here, a perfect square has 5 as a factor, then its square root will also have 5 as a factor. So here we have p square having 5 as a factor. That means 5 will be a factor of p also. So we say 5 is a factor of p square. This implies or tells us that 5 is also a factor of p. Square root of p square is p. Now, important. Here if you see 100, it's 5 multiplied by 20 and 10 is 5 multiplied by 2. What do I mean to explain here is the multiple of 5 or the number multiplied with 5 in both cases 100 and 10 are two different numbers. So we know that p square is 5 multiplied by q square. That means p will be 5 multiplied by some other number. So let's take it as a. Now we'll square it on both the sides again. So we'll get p square and 5a the whole square. Okay, so that will be p square equals to 5a the whole square, which is 25 square. So we get p square equals to how much? 25 square. Just above we got p square as 5q square. And now we got p square equals to 25p square. So let's put them and give them a number. So this will be equation 2. And the above equation, let's number it as 1. Which equation? P square equals to 5q square. We are going to number it as 1. So from these two equations, that is 1 and 2, because both are representing p square. So we'll say from 1 and 2. Both are p square. So both the right hand side will be equal. That means we can say 5q square equals to 25a square. Now we are going to take the 5 on the other side. So that will divide. So we get q square equals to 5a square. Again, what happens here? 5 is a factor of q square. Correct? So we'll say 5 is a factor of q square. Sorry. So can we say 5 is a factor of q? Yes, because that's what we showed in the example of 100 and square root of 100 as 10. So we say 5 is a factor of q. Now here what we are getting, the 5 comes out to be a factor of p and q both, right? So can we say the HCF, or the highest common factor of p and q, turns out to be what? 5. But is it right? Because we already took a condition that p and q are co-primes. That means the HCF of p and q should be 1 and not 5. So our assumption here is wrong. So we will say, but p and q are co-primes. So our assumption is wrong. Thus root 5 is irrational. Therefore our assumption is wrong. Sorry. So what we can say, that root 5 is irrational. So again, what was the step? We took the opposite of the given statement. That means we took an hypothesis and we said let us consider it to be an rational. And we took the definition of rational as p by q, and we went ahead proving it. Sorry, it's irrational here. And we came across a situation where we said that p and q both have 5 as the factor. But it's not possible because we already have put a condition for p and q that they have to be co-prime. Means only one can be their common factor. Okay. So this is how we prove root 5 irrational. Hope it is clear. I have taken 2 questions as your extra practice question. You can go through this again and you have to follow the same method to prove it. The 2 homework questions or extra practice questions are: prove that root 3 is irrational and root 7 is irrational. Thank you.